Welcome to Odd Problems with Mr. Lorenz, the part of your day where I'm going to run through some odd problems from your worksheet with you. Now, I'm going to try and do this fairly quickly with you. Keep in mind that you might want to slow it down to take a look at it. What we're looking at here are two log base 7s that are equal to each other, which means the interior portions must also be equal to each other. We have a simple equation, no longer logs involved. Simple thing for us to solve. We can subtract 2x from both sides. We can take and add 7 to both sides. And after we do that, it's actually a fairly straightforward problem. There, dividing both sides by 2. Sorry, I didn't show that. Problem 3 here, very similar. We have two equal logs. So we can set the interiors equal to each other. If we add 2x to both sides, we end up with 8 plus x being equal to 3. If we subtract the 8 from both sides, we find out very quickly that x is -5. Now we're going to come back to that negative a little later. It's not a problem here. A little more of a challenging problem here. We have 3 different logs. I can't just take away the log values. Instead, first I need to use some log properties to rewrite this as 2 equal logs. So we're going to take the right side here, write it as a single log base 3 of one thing, and that one thing is an x minus 1 over an x plus 1. And now we can simply take the interiors of those logs, setting them equal to each other. All right, now if we do that, you might realize it's a little bit different in how we're going to solve it from here. But the log portion is done. We just need to cross multiply, get ourselves something that we can work with, and continue to solve x minus 1. So we'll get an x squared plus 5x plus x plus 5 equal to an x minus 1. When we move things to one side, that's a plus of 1. You see that we have an x squared plus 5x plus 6 equal to 0. Setting it equal to 0, we could use a quadratic formula. I instead am going to just factor things that multiply to 6 and add to 5, being 2 and 3, which means our x values would be -2 and -3. And it seems like we are done. However, you're not allowed to take the log of a negative number. And it's not the fact that -2 is a negative number or that -3 is a negative number, but rather, if I look at even just one portion of what we had before, log base 3 of x minus 1, if I were to plug either one of these two guys in there, we would have the log of a negative, and that's not allowed. So with that in mind, we're going to go ahead and say we actually have no solution. Continuing on to number 7, once again we have two equal logs. We can simply take the insides, set them equal to each other. Really the only difference here is that we are starting with a quadratic situation right away. If we subtract 3x and subtract 6 from both sides, we'd of course set it equal to 0. A reminder that you could use the quadratic formula right there. The other thing you could do is factor it. Things that multiply to -6 and add to -5 are -6 and +1, which means our x values are 6 and -1. And if you take either of those two numbers and plug them back up in the top logs there at the beginning, you'll find that neither one of them is going to cause a problem with the whole negative issue that we dealt with in the last problem. This problem is going to change our paces a little bit. We don't have two equal logs. We're not going to set things inside of logs equal to each other. Instead, we're going to rewrite in exponential form. If I take this and rewrite it in exponential form, we'll have 25 to the 5 halves power is equal to x. Your calculator will tell you that's 3,125. If you want to remember how that's 3,125, remember the half power is talking about a square root. So really what I have here is a 5 to the 5th power. That's my 3,125 that x is. This problem may appear very similar at first, but in truth, this x as the base of the log makes it quite different. And yet at the same time, the first thing we're going to do is take and rewrite it in exponential form. Once it's in exponential form, you may remember to solve an equation like this, we would simply raise our exponent side to a secondary exponent. I'm just going to raise both sides to the 2/3 power. That will get these two powers. Remember, they're going to multiply together, and they're going to give you an x to the 1st power, or, well, x. Over here we have a 27 to the 2/3 power, or a cube root of 27 squared. Cube root of 27 being 3 squared, and we find out that x is 9. Our last problem has a couple of things that happened throughout the worksheet. I really don't think this is even our hardest problem that we've done today. But I think that might have been the one where we had no solution if we weren't paying attention. First thing I'm going to do is get my logs on onto one side. If I get my logs onto one side, I can write them as a single log, and that will allow me to write it in exponential form. So we'll take our logs, write them on one side. Now we have a 2 to the 4th power being equal to an x plus 4 over an x minus 1. We'll cross multiply from there, keeping in mind that this is really a 16. So we'll end up with a 16x minus a 16 is equal to an x plus a 4. Do a little adding and subtracting from there. We'll get a 15x is equal to a 20, and our x value becomes 20 over 15, or rather 4/3. I hope that's helpful. I hope it wasn't too fast. I didn't want the video to be too long. Remember, as you go through these videos over the next couple of weeks or months or whatever it is, that you can always slow them down to listen to them, pause them along the way, make them work for you, not against you. All right, you have a good day. See you later.